Hello everyone. So for this lecture we will see about the motor on load with the constant excitation. That means already we have seen in the last lecture about the construction working principle of the synchronous motor, as well as after that we have seen about the different torque which are produced by the synchronous motor at the different stages. Okay. So for this lecture we will see about the motor on load with the constant excitation. As we know that synchronous motor always need excitation, we provide the DC excitation to obtain its synchronous speed. Okay, because as we know that synchronous motor always runs on a synchronous speed. Okay, so to obtain the synchronous speed we should supply the DC excitation to the synchronous motor. Okay, जेव्हा आपण DC excitation जेव्हा मोटरला देतोय त्याच केसमध्ये मोटर तुमचा सिंक्रोनस स्पीडला रोटेट होणार आहे. ओके, नॉर्मली वी आर स्टार्टिंग द सिंक्रोनस मोटर विथ similar to that of your induction motor. Okay, and once your motor achieves the speed nearly to the synchronous speed, then we are switching on the DC excitation so that the motor will receive the synchronous speed. And once we have supplying the DC excitation, obviously the DC motor, this synchronous motor will run as a synchronous motor will run at a synchronous speed. Okay, now we will see for this lecture, if we are applying the constant excitation and if you have the constant load on the motor, then what are the different changes in working of the synchronous motor, we will discuss for this lecture. Okay, so before considering the detailing about the constant excitation, we will see about the basically the back EMF concept. Already we have seen in the previous semester about the concept of back EMF. To similar to that of a back EMF. Now, as we've seen in the previous, that means in DC motion, when the DC motor is running on a supply of V volt, then rotating back EMF EB setup. Okay, as we know in the semester. So because of this back EMF which is produced by the armature conductors, the resultant voltage across the back EMF is nothing but a V minus EB. That means back EMF म्हणजे normally counter EMF किंवा back EMF म्हणजे काय होतं की जेव्हा तुमचा रोटर फिरायला लागणार आहे. ओके, रोटर फिरायला रोटर मध्ये करंट असणार, रोटरचा फ्लक्स मुळे काय होतं, द स्टेटर कंडक्ट ट्रॅक्स एज अ स्टेशनरी पार्ट. So in that case back EMF is also induced in the this synchronous motor. Similar to that of your DC motor, the back EMF is also exists, or back EMF is also produced in the DC motor. Okay, now this back EMF EB, that is we called back EMF EB, is set up in the armature by the rotor flux which opposes the applied voltage V. Okay, similar to your back EMF in DC, the back EMF is also produced in the synchronous motor by this armature we call stator because of the rotor. Okay, and which the back EMF as the known back EMF, हा back EMF काय करतोय तर सप्लाय व्होल्टेज जेव्हा मी अप्लाय करणार आहे, थ्री फेज जे इनपुट देणार आहे, इट अपोजेस टू द सप्लाय व्होल्टेज और अप्लाइड व्होल्टेज V. Okay, this back EMF depends on the rotor excitation only. In the DC, back EMF depends on the speed, but for this synchronous motor, the back EMF is only depends on the rotor excitation. Okay, the net voltage, the total voltage or the available voltage in the armature, which is the vector difference, not arithmetic. It's a vector difference of V and EB. Okay, normally DC मध्ये करतो V minus EB direct घेतो back EMF ला. But for this here AC system, we are applying using the vector difference between the voltage V and EB. Okay, the armature current is obtained by dividing this vector difference of voltage by armature impedance, because here AC. So instead of resistance here, आर्मेचर करंट तुम्ही कसं करतो डीसी मध्ये IA इक्वल्स टू V मायनस EB अपॉन RA असं तुम्ही डीसी मध्ये काढत होता. बट इन AC we should consider the impedance. So IA is equals to vector difference between V minus EB divided by Z, that we call the armature impedance. Okay, so we will see about what are the different excitation, what is the changes in the machine, about the excitation. If there is a change in excitation, what are the changes, we will see detailing. Okay, now now a synchronous motor is said to have the normal excitation when the EB is equals to V. That means if the back EMF is equals to supply voltage V, then we call it as a normal excitation. If field excitation is such that EB is less than V, if field excitation such that EB is less than V, the motor is said to be under excited. म्हणजेच काय, जर सप्लाय व्होल्टेज जर आपण फील्ड एक्सायटेशन जर असं दिलं, मोटरला आपण फील्ड एक्सायटेशन देतोय आपण. ओके, जर EB is less than V असेल तर we call the motor is said to be under excited. In both these conditions it has a lagging power factor. म्हणजे काय होणार आहे, या जर तुमचं एक्सायटेशन जर back EMF, already we know that back EMF is produced. If back EMF is equal to supply voltage, or if back EMF is less than supply voltage, then we call the motor is running under the motor is said to be under excited. Okay, and if this is nothing but this figure, okay, lagging power factor, that means both this figure, that means 13.38.5, that means this figure, okay, this figure indicates if EB is equals to V, if this is for, and EB is equals to, EB is greater, if EB is less than V. So this particular phasor diagram indicates if the machine is EB is not is EB is equals to V, or EB is less than V, then this machine act as the under excited. And in that case, if the machine is acting as an under excited load, then machine always draws a lagging power factor current. Okay, if the machine is under excited, then the machine always draw the lagging power factor current. Lagging म्हणजे काय, voltage पेक्षा current lag असणार, कमी मागे असणार. So in that cases always the machine lags, machine draws only the lagging power factor current. And in other cases, if EB is greater than V, that means back EMF is greater than supply voltage, then the motor is said to be over excited. And in that cases, motor always draw a leading current. Okay, leading current. Synchronous motor तुमचा unity power factor current draw करू शकते, lagging power factor current draw करू शकते, किंवा leading current draw करू शकते. It is this feasibility is only possible in the synchronous motor. जर EB is equals to V असेल, or EB is greater than EB is less than V असेल, तर machine is acted under excited. In that cases, motor always draw the lagging power factor current. But if the machine we call EB is greater than V, then the machine is said to be over excited. In that cases, the machine will draw the leading current. Okay, that is the leading power factor current. Now, so these are the phasor diagrams with respect to the excitations. So for this, if we have the lagging power factor ratio, that means as we know that if the supply voltage is equals to back EMF, then the machine act as a lagging power factor current. If a machine act as a lagging current, or machine will draw the lagging power factor current. So इथं काय होईल, V जर आहे, म्हणजे जर इथं जर EB आपल्याला माहिती आहे की EB आणि EB एकमेकाचे अपोजिट आहेत, हे माहिती आहे ना आपल्याला, वेक्टर डिफरन्स म्हणजे IA हा IA करंट कसा झाला, इट इज नथिंग बट अन डिफरन्स बिटवीन V अँड EB. म्हणजे V मायनस EB असेल तर तुमचा काय होतं, V मायनस EB डिवायडेड बाय Z म्हणजे तुमचा आर्मेचर करंट असणार आहे. सो दिस ER इज नथिंग बट इट्स अ रिझल्टंट EMF. रिझल्ट EMF पुन्हा कशामधला काढला, तर हा व्होल्टेज V आणि EB म्हणजे the resultant EMF we have drawn, which is resultant of supply voltage and the back EMF. Okay, in that case when EB is equals to V, so this in that case motor always draw the lagging power factor current. We can see that lagging armature current here is lagging as well as this. If the EB is less than V, also armature current is lagging. But in next cases, if EB is greater than V, in that case the motor always draw the unity power factor current. Okay, here not lagging, it's leading should be. If the motor is if the EB is greater than V, that is supply voltage, then the motor always draw the leading power factor current. So we can, in that figure we can see that now here voltage V and current I, that means armature current I, it always leads than the V. Okay, so these are the basic terminals. So we will, as per the syllabus, we will say about the effect of increased load with constant excitation. If we are having the constant excitation and if the load is increased, then what will happen in the synchronous motor, we will see detail. Okay. Now for this lecture, we will for this session we will study about the effect of increased load on a synchronous motor under the condition of normal and अंडर एक्साइटेशन ओव्हर एक्साइटेशन. म्हणजे आपल्याला काय करायचं आहे, लोड तरी इन्क्रीज करायचा आहे. लोड इन्क्रीजचा आपण इफेक्ट कसं बनवणार आहे, लोड तरी वाढवायचा आहे. लोड जो लोडचा इफेक्ट आहे, इन्क्रीज लोडचा इफेक्ट आहे, वी विल सी under the three conditions we called for normal excitation, second under excitation and third over excitation. And normal excitation म्हणजे काय, back EMF is equal to supply voltage म्हणजे normal excitation झालं. अंडर एक्साइटेशन म्हणजे काय, बॅक EMF is less than supply voltage म्हणजे अंडर एक्साइटेशन झालं. आणि थर्ड म्हणजे ओव्हर एक्साइटेशन म्हणजे काय, back EMF is greater than supply voltage. These are the three conditions. Okay, आणि फर्स्ट टू कंडिशन नॉर्मल एक्सायटेशन असू दे किंवा अंडर एक्सायटेशन असू दे, इन दॅट केसेस सिंक्रोनस मोटर ड्रॉ लॅगिंग करंट under excitation as well as normal excitation. But in case of leading this over excitation, synchronous motor always draw the leading current. Okay, leading current म्हणजे काय? Armature current is lead by the voltage V. Okay. Now we are considering first case, it's a normal excitation. Now this figure, in that case we have seen figure shows the condition when motor is running with a light load, and so that torque angle alpha is small, this one. Okay, so here as we know that Eb is equals to V under normal excitation conditions, Eb is equals to V. So this motor draws a lagging current, and we are considering that the load is very small. Okay, the load is very small. So hence, if the load is very small, obviously the torque is very small, and hence the resultant of these two, that means Eb and V, we call it ER1, is also small. Okay. Hence, IA1 is also small because this IA1 armature current always depends on the load. म्हणजे लोड वाढला obviously armature current वाढणार आहे, आणि armature current वाढला तर obviously back EMF वाढणार. Okay, so in that cases we are considering that we have the Eb is equals to V, back EMF is equal to supply voltage, and we have the smaller light load. Okay, that is called a smaller load or light load cases. In that case, if the load is small, obviously the armature current is small, and if the armature current is small, then this V and Eb, that means these two, the ER1 is smaller. Okay, now suppose that load on the motor is increased. Okay, load on the motor is increased. Now what will happen for meeting this extra load? Motor must develop more torque by drawing more armature current. Obviously काय होईल, लोड वाढला तर काय होईल, मोटरला जास्त ताकद लावायला लागेल ना लोडला सप्लाय करायला. सो जास्त ताकद लावायला लागेल म्हणजेच काय, तर मोटर विल ड्रॉ द लार्जर करंट. वी कॉल द आर्मेचर करंट विल get increased. That means motor will draw more armature current. Okay, so this one, in that cases, here first case is armature current is smaller because of load smaller, so ER1 is smaller. ER म्हणजे काय, हा दोन्हीचा रिझल्टंट आहे, EB आणि V चा रिझल्टंट आहे. So in that case VB and here ER2 is increased. Okay, now what will happens, for there are cases, what actually happens is under rotor falls back in a phase, that is load angle increase to alpha 2 as shown in this figure. Okay, load, if the load is increased, obviously load current is, armature current is increased, torque is increased, so obviously the alpha 2, that is load angle, is increased. As well as second condition, the resultant voltage in armature increase considerably to new voltage ER2. Obviously if the current is increased, the load voltage, resultant voltage is also increased. As a result, IA1 is increases to IA2. Obviously current is increases, okay, to develop the new torque. And also phi1 increases to phi2. Already here phi1 is there here, but phi1 is increases compared to phi2. Okay, and hence these are the conditions for the normal acceleration. For the second case, under excitation, as shown in figure 1338.16b here, under excitation, that means what, जर तुम्ही if my back EMF is less than the supply voltage, it's called, this case is called as under excitation cases. Okay, so in that cases I1 lags behind V by a large angle phi1. Okay, I1 lags behind V. Okay, इथं बघा, हा तुमचा large angle phi1. In that case, suppose तुम्ही जर voltage परत जर तुम्ही इथं काय, normally as we know that in the under excitation cases, back EMF is less than the supply voltage V. Okay, under this is nothing but a conditions. So in that case, what will happen? This IA1, it has lags by a certain degree. We call it phi1 degree. In that case, suppose we increase the load on the synchronous motor. So in that case, what will happen? Again, this firstly there is a smaller load. So in that case, we obtain the smaller ER1. But if we increase the load on the synchronous motor, then obviously what will happen? The IA2, the load current will increase. For initially it was IA1, the smaller load होता तेव्हा IA1 होता. Okay, जेव्हा लोड वाढला तर काय होईल? लोड वाढला म्हणजे आर्मेचर करंट वाढला म्हणजे IA2 झाला. So IA2 वाढला तर obviously ER2 वाढणार. So this phasor diagram is related with the under excitation. And third one, it's a over excitation. So in that over excitation cases, what will happen? Now EB is greater than V, म्हणजे back EMF is greater than V. So म्हणजे काय, माझं इनिशियली काय झालं, सपोज मी IA1 कन्सिडर केला, IA1 माझा स्मॉलर आहे. ओके, So Ia1 load कमी आहे, Ia1 smaller आहे, it is leading with the VM. So if I increase the load on the synchronous motor, in that case over excitation, obviously my Ia2 will get increased and there is a small power factor is power factor is going to less compared to the previous one. So these are the conditions. So these are the summary. That means main points regarding the above discussions. Three cases means under excitation, over excitation, as well as normal excitation. As load on the motor increases, IA increases regardless of excitation, because excitation, whatever may be excitation, it may be under excitation, it may be over excitation, or it may be normal excitation. If you increase the load on the synchronous motor, obviously the armature current is increases. Okay. Now second case, for under and over excited motors, power factor tends to approach unity with increase in load. That means is most important part. So if we, for these two cases, for under and over excited motors, if we increase the load, then what will happen? The power factor is approaches towards the unity. Already we have seen, if we have runs the motor in under excited condition, under excited condition ला काय होतं, under excited condition ला मोटर तुमचं लॅगिंग पॉवर फॅक्टर ड्रॉ करत होता. ओके, आणि ओव्हर एक्साइटेड लीडिंग करत होता. But if we increase the load under these two conditions, that means under excited and over excited conditions, then the motor tends to run, or motor tends to approach towards a unity power factor current. Okay, next third, both with under and over excitation, change in power factor is greater than in IA with increase in load. That means what? If we increase the load on the synchronous motor in both conditions, that means under excited condition, over excited conditions, there is a changes in the power factor takes place. Okay, and last one, with a normal excitation, that means normal excitation, if EB is equals to V, when load is increased, change in IA is greater than in power factor, which tends to become increase in lagging. That means if we increase the load on normal excitation condition, obviously current is increases, armature current is increases. In that case, this armature current draws a lagging power factor nature current. Okay, so this is the nothing but the effect of excitation, the change in excitation with a constant load. Okay, now the next part we will see about this one. Next, this part, that is the effect of changing excitation on constant load. Then already आपण पहिल्या पॉइंटला काय सांगितलं की मी एक्साइटेशन मध्ये कॉन्स्टंट आहे, माझं जर लोड चेंजिंग होत असेल तर काय परिणाम करते, काय इफेक्ट होते. नाउ फॉर दिस लेक्चर वी विल से अबाउट, फॉर दिस पॉइंट वी विल से अबाउट इफेक्ट ऑफ एक्साइटेशन, चेंजिंग एक्साइटेशन. एक्साइटेशन मी चेंज करा, लोड कॉन्स्टंट आहे. आधी काय बघितलं मी, तर लोड माझा लोड व्हॅरिएशन आहे, एक्साइटेशन कॉन्स्टंट आहे. ओके, मी तीन कंडिशन कन्सिडर केलं, अंडर एक्साइटेशन, ओव्हर एक्साइटेशन आणि normal excitation. Okay, but here in that case I consider as effect of there is a load is constant, but excitation is going to change. Okay, now as shown in figure this is, suppose a synchronous motor is operating with a normal excitation, that is EB equals to V at unity power factor with a given load. That means these conditions. Okay, they are considering this figure. Okay, so if we assume that motor is operating with a normal excitation, that is EB equals to V at unity power factor with a given load, if RA, that is armature resistance, is negligible as compared to XS, that is the synchronous reactance, then the IA lags ER by 90 degree and is in phase with V because of power factor is unity. That means this one. Okay, म्हणजे आपण ह्या फिगर मध्ये काय बघतोय, तर if my this particularly if my machine is rotating, synchronous motor rotating at a normal excitation cases, in the first figure, this one. Okay, so मी काय केलंय बघा, इथं मी नॉर्मल एक्साइटेशनला मी दिलेलं आहे, आणि जर मी इथं I assume that RA, that is armature resistance, negligible than XS, that is the reactance, then IA lags ER by 90 degree and in phase with the V. म्हणजे इथं काय झालंय बघा, exactly. If I assume that this figure, if I assume that my load is constant and it is under the normal excitation, that means EB equals to back EMF equals supply voltage. In that case, what will happen? Now this IA is lags by this ER, that means resultant EMF exactly 90 degree lagging. Okay, this resultant EMF, this IA is lags by exactly 90 degree with respect to the ER, the resultant EMF. But this IA, it is in a phase with the supply voltage V. That means what? This IA, that is armature current, it is in a phase with supply voltage. That means this case the motor will draw as a unity power factor current. As I said earlier, the synchronous motor can work as a unity power factor current, leading power factor current, lagging power factor current. Depending on application, तुम्ही synchronous motor कसल्याही केसला रन करू शकता. तसं इंडक्शन मोटर तसं नाही. इंडक्शन मोटर always draw the lagging power factor current. But for this synchronous motor can operate under unity power factor nature load current as well as a lagging power factor current or the leading power factor current. Okay, now this point is discussed. Now, if we excitation is decreased, okay, if we have the load is constant, if we decrease the excitation, okay, now suppose due to decrease in excitation, back EMF is reduced to EB1 already here, this figure, okay. Now assume करा की माझा बॅक EMF EB आहे, ओके, आणि मी काय केलं आता माझा एक्साइटेशन डिक्रीज केलं म्हणजे काय झालं, सप्लाय व्होल्टेज बी पेक्षा माझं एक्साइटेशन डिक्रीज झालं, म्हणजे बॅक EMF डिक्रीज झाला, म्हणजे ऑलरेडी इट वॉज EB, नाव इट विल चेंजेस टू EB1 बिकॉज ऑफ डिक्रीज इन द बॅक EMF or decrease in the excitation. Okay, now by same angle alpha, the resultant voltage ER1 causes to lagging current IA1 to flow. म्हणजे ह्याच्याने काय होणार आहे, जर मी डिक्रीज केलं म्हणजे एक्साइटेशन मी कमी केलं तर काय होणार, माझा बॅक EMF ची व्हॅल्यू सुद्धा कमी होणार आहे EB1. ओके, आणि एकदा का EB1 कमी झाला तर ऑब्विसली माझा IA1 सुद्धा कमी होणार आहे. ओके, प्रिव्हियसली माझा बॅक EMF नॉर्मल होता, EB इक्वल्स टू V होतं, तेव्हा काय होतं नॉर्मल एक्साइटेशनला माझा बॅक EMF सप्लाय व्होल्टेज इतकं होतं. But if I decrease my excitation, then what will happen? My back EMF value changes to EB1. Already previously it was EB, but acceleration कमी केल्यामुळे काय होतं, तुमचा आता EB1 इतका back EMF होता आणि back EMF कमी झाल्यामुळे now armature current also changes from IA to IA, म्हणजे armature current सुद्धा माझी आता IA1 इतकी व्हॅल्यूला चेंज झालेली आहे. Okay, now what will happen? Even though IA1 is larger than IA in magnitude, incapable of producing necessary power VIA for carrying constant load, because IA1 cos phi1 component less than IA1. Hence, it becomes necessary for load angle to increase from alpha 1 to alpha 2. It increases back EMF EB1 to EB2, which in turn increases resultant voltage from ER1 to ER2. म्हणजे इथं काय झालंय बघा, because of resultant voltage ER1 causes to lagging current IA1 to flow, even though IA1 is larger than IA1. Now see, we will see this figure. Okay, now what will happen, now we are here in that case we are reducing the back EMF. If in that case we are reducing the this we called excitation, आणि जर आपण एक्साइटेशन जर कमी केलं सिंक्रोनस मोटर तर काय होणार, बॅक EMF माझं कमी होणार, EB1 होणार. ओके, बॅक EMF कमी झाला काय होईल, आर्मेचर करंट कमी होणार आहे. Now, even though this armature current lower the armature current back मध्ये armature current माझा IA होता तो IA1 इतका चेंज झाला, but this change in the IA1 also need to produce the armature the respective torque. म्हणजे लोड तरी कॉन्स्टंट आहे, माझा आर्मेचर करंट तरी बदलला आहे, आर्मेचर करंट जरी बदलला असेल तरी आर्मेचर करंट needs to produce that amount of torque because my load is constant. Okay, so to generate the new torque, to generate that amount of torque, armature current changes to IA2. म्हणजे काय झालं बघा, I will explain once again. Now, if I reduce my excitation कमी केलं तर काय होईल, बॅक EMF सुद्धा कमी होईल, बॅक EMF कमी झाला तर काय होईल, आता माझा आर्मेचर करंट IA जो आधी होता तो आता IA1 इतका होईल, पण लोड माझं कॉन्स्टंट आहे ना, लोड कॉन्स्टंट असल्यावर काय होईल, जो काय नवीन तयार झाला IA1 आहे त्याला आता मात्र लोड मला कॅरी करायचा आहे. सो टू प्रोड्यूस दॅट amount of torque to carry such load, my armature current is increased to IA2. म्हणजे armature current IA1 होता, हा कोणा IA1 झाला, EB1 मग IA1 झाला होता, but लोड कॉन्स्टंट असल्यामुळे मला तो लोड तरी मला डिलिव्हर करायचा आहे, लोड तरी मला नेसेसरी टॉर्क क्रिएट करायला. नाव IA1 becomes as a IA2, and obviously if there is change in armature current, obviously there is a change in the ER2 also. Okay, Now that means resultant EMF is increased. And now third case we called excitation. If we increase the excitation, this figure we will see in the this one. Okay. The effect of increased field excitation is shown in the figure C, where increased EB1 is shown original load angle alpha 1. That means this one, alpha 1, EB1. This is nothing but increased EB1. Okay. The resultant voltage ER1, causes a leading current IA1, this one, okay, leading current IA1, okay, whose in phase component larger than IA. That means what, if I increase the excitation, obviously the back EMF will increase to EB1. okay, सुरुवातीला EB होता, आता EB1 increase झाला. okay, आणि एकदा का increase EB1 झाला तर obviously my current is also increases, we called IA1. okay, hence the armature develops more power than the load. okay, hence the armature develops more power than the load. म्हणजे लोड माझा काहीतरी कॉन्स्टंट आहे, but still because of the increase in the IA1, the armature develops more power. okay, and hence more power than the load on the motor. Accordingly, load angle decreases from alpha 1 to alpha 2, alpha 1 to alpha 2. And if we decrease the load angle, obviously the ER1 resultant voltage is also changes from ER1 to ER2. म्हणजे ओव्हर एक्साइटेड मशीन झालं तर काय होणार आहे, तर माझा EB1 चेंज होणार आहे, IA1 सुद्धा बदलणार आहे. बट इन दॅट केस व्हॉट विल हॅपन, मोटर जनरेट मोर पॉवर, म्हणजे जेवढे काय नेसेसरी पॉवर जनरेट करायला पाहिजे होती त्याच्यापेक्षा सुद्धा मोटर आता जास्त पॉवर डेव्हलप करणार आहे अंडर इन ओव्हर एक्साइटेड कंडिशन्स. And in that case, what will happen? If motor will create the larger power compared to, with larger power, then what will happen? Now in that case, the load angle decreases. Load angle previously it was alpha 1, now it decreases to the alpha 2. And because of this, my resultant EMF also changes. Previously it was ER1, but आता काय झाला, माझा load angle is alpha 2 कमी झाला, मग माझा ER2 सुद्धा कमी होणार आहे. Okay, so consequently armature current decreases from IA1 to IA2. म्हणजे ऑब्विसली माझा लोड अँगल चेंज झाल्यामुळे मला पॉवर जास्त करायची गरजच नसल्यामुळे लोड अँगल चेंज होणार आहे. आणि लोड अँगल एकदा चेंज झाला तर माझा ऑब्विसली आर्मेचर करंट सुद्धा कमी चेंज होणार. म्हणजे प्रिव्हियसली इट वॉज IA1, बट आता माझा IA2 इतका चेंज होणार आहे. ओके, that means in that case armature develops power sufficient to carry the constant load on the power. म्हणजे previously due to over excitation condition, now the motor develops larger power than the required. Okay, in that case what will happen, the armature current is also more compared to the load. But if armature current is more, obviously the back EMF is more. In that case, due to over excited conditions, my load angle is going to changes. And if my load angle is going to change, that means load angle is going to decreases. In that case, if the load angle is going to decrease, obviously the resultant EMF ER2, this resultant EMF is going to decrease. And if the resultant EMF is decrease, then armature current is decrease. Armature current decrease झाला म्हणजे काय, जितका काय माझा नेसेसरी जितकं मला द्यायचं आहे तितकंच तो जनरेट करणार. Okay, so these are nothing but the excitation, effect of excitation of the generator.